Our sun, a seemingly tranquil giant in the sky, has recently roared back to life. In May 2025, a sunspot region designated AR 4087 unleashed a series of significant solar flares, capturing global attention. These weren't just any flares, they were powerful X-class flares, the most intense category, capable of causing noticeable disruptions on Earth. One particular flare, an X 2.7, was the strongest of 2025 so far, briefly disrupting radio communications across several continents. This event served as a stark reminder of the sun's immense power and its potential to impact our technology-dependent world. Thankfully, the coronal mass ejection associated with this flare missed Earth, hurtling instead towards Mars. While we escaped the full brunt this time, the active sunspot region remained facing Earth for several days, keeping scientists and the public on high alert for further solar storms. Interestingly, this solar activity has been linked to seismic activity and earthquakes, often occurring around the same time as these solar events. According to usgs.gov, 232 earthquakes were recorded in just one day from around the world, and in just 1 week, 1,832 earthquakes worldwide, at least 3 of which being over 6.0 magnitude. This recent activity underscores the critical need to understand and prepare for the potential consequences of our sun's unpredictable nature. Solar flares are sudden, intense bursts of energy from the sun's surface, like colossal explosions, flinging radiation and charged particles into space. Imagine a gigantic bubble bursting on the sun's surface, releasing a blinding flash of light and a shower of energy. These flares are classified by their strength, from the mild A and B class to the powerful C, M, and X class. Often accompanying these flares are coronal mass ejections, or CMEs. Imagine a billion tons of superheated gas, a fiery solar wind, surging outwards from the sun at incredible speeds. When directed towards Earth, CMEs can interact with our planet's magnetic field, triggering geomagnetic storms. The consequences of these storms can be far-reaching. Imagine widespread radio blackouts, disrupting communication networks, GPS systems, and even airline operations. Imagine electrical grids overloaded, causing power outages that could cripple entire cities. These are just some of the potential impacts of severe solar storms, highlighting our vulnerability to these celestial events. While the recent solar flares were significant, they pale compared to the most powerful storms our sun is capable of unleashing. History provides a sobering reminder of the potential consequences of solar fury. Imagine the year 1859. A massive solar storm, now known as the Carrington Event, struck Earth. Telegraph systems, the internet of their time, went haywire, sparks flew from wires, and operators received electric shocks. Auroras, normally confined to polar regions, lit up the skies as far south as the Caribbean. More recently, in 1989, a powerful geomagnetic storm caused by a CME led to a 9-hour blackout in Quebec, Canada, plunging millions into darkness. These historical events demonstrate the disruptive potential of solar storms, reminding us that our modern world, heavily reliant on technology, is even more vulnerable today. Given the potential consequences of a major solar storm, what steps are we taking to protect ourselves? Imagine a global early warning system, like a network of space weather satellites, constantly monitoring the sun for any signs of trouble. These satellites could provide critical time for power grids to be protected, satellites to be shielded, and communication systems to be reinforced. Imagine engineers developing more resilient power grids, less susceptible to the disruptions of geomagnetic storms. Imagine scientists working on advanced forecasting models, enabling more accurate predictions of solar storms and their potential impacts. These efforts are underway, but much more needs to be done. Raising public awareness about the risks of space weather is crucial. Just as we prepare for hurricanes and earthquakes, we must also be prepared for the sun's fury. By understanding the risks and investing in mitigation strategies, we can minimize the impact of future solar storms and safeguard our technological civilization.